Okay, now to start with, we're talking about derivatives, right? Derivatives. Now, what does derivative mean? When we say d by dx, simply the symbol, it means derivative with respect to x. So if I write d by dx of y, it means a derivative of y, where y is a function with respect to x. And when we write dy by dx, it means change of y with respect to change of x. So this can be very clearly understood with the help of a curve where if along x and y axis, if we have this curve, this is x axis, this is y axis, and if you see that what is the change along y axis when there is a change along x axis. So basically when you say delta y upon delta x, it is nothing but slope of the tangent or the gradient of the tangent, right, at a point. Say the point is this p. Okay, now that is a basic derivative understanding of derivative as to what does derivative mean. Moving further with our work, the basic derivatives needs to be done with the help of a formula. So d by dx of x raised to n, the power root, is n into x raised to n minus 1. And similarly, you have all the formulas with sin x, cos x, and all the other terms, right? Now, when this all is done, d by dx of, if I ask you x raised to 7, so according to this, the answer turns out to be 7 into x raised to 6. But if I ask you what is derivative of, say, 7 into x raised to 5, so you see a constant is multiplied to a variable. In that case, you take a constant aside and differentiate x raised to 5. So again, 7 into x raised to 5 is 5x raised to 4. So the whole answer is 35x raised to 4. Is that clearly understood? So that is a basic thing which we say that derivative of constant into f of x is constant aside and then you differentiate f of x. Now this writing derivative of f of x can also be written as k into f dash of x. One more way of writing it. Now, further on, when you see derivative of a constant, so as we say, what is derivative? Derivative is change in this with respect to change in x. But when a constant is there, how can there be a change? So derivative of constant is 0. You can remember it that way, right? Okay. Further in, if you have two terms multiplied, like in u into v, where u is a function of x, v is another function of x, right? And then if you're asked to differentiate this, you can go by a formula. What is it? U derivative of v plus v derivative of u. Can be written this way also, u v dash plus v u dash. Do you understand this? Right? So if I take an
Sir, can you repeat
example,
that once again?
I'll explain that. I'll explain that with the help of an example to make you understand clearly. Say d by dx of sin x into x raised to 7. So there are two functions. This is f of x, this is g of x. So you'll use this formula. What is this formula? Take any one as u, other as v. Keep u as it is and differentiate x raised to 7. So it becomes 7x raised to 6. Then further on, you take x raised to 7 as it is and differentiate sin x. So that will give you cos x. So that is your complete answer. That is basically what we say is your product rule. Product rule. Is that clearly understood?
Yeah, sir.
Okay. Further on, here, if I have d by dx of in a similar way two functions which are divided, I'll directly take a formula u by v. Then the formula works as vu dash minus uv dash upon v square, right? Where u and v are functions of x. U dash means, what does u dash mean? Derivative of u with respect to x. Is that clear? Let's take an example to understand, and this is basically known as quotient rule. So it is quotient rule. So here you see example d by dx of u by v. So just let's take it as sine x upon again x square, a simpler one. So let's follow the formula. V, so x square into u dash, that is sin x her derivative, that is cos x, minus u, that is sin x as it is, v dash derivative of x square, that is 2x, upon v square, so whatever is v, it's square, so x square ka square. So this is basically your answer. Do you understand this?
Yeah.
So that is quotient rule. Now, once we are done with quotient rule, what can we go for it further is derivative of composite function or chain rule. Now, this is the most important part of derivative. It seems to be tough to start with, but one of the easiest concept if you try to understand. And why do you do it? Let's understand that first. Once again, what is derivative of x raised to 7? 7x raised to 6. But herein, if I ask you what is derivative of 3x plus 5 raised to 7. So again, it is some bracket raised to 7. This was x raised to 7. So we treat this bracket as a variable, right? And we write it as 7 into bracket raised to 6. The same way. 7 into x raised to 6, right? So 7 into bracket raised to 6. So what did we do? We used or we differentiated this function. Which function? Variable raised to 7. That is an algebraic function we differentiated. But what about the derivative of something which is there in the bracket? So we need to differentiate that also. Do you understand this? So this works like a chain. See, this is a chain. You differentiate the outside thing, then you go in. When you go in, you differentiate the next layer. Then you go in, you differentiate the next layer. Then you go in, you differentiate the next layer. The same way, I differentiate the first layer, that is 7. Done. Then I don't have to worry about this. Now this will just keep on repeating as it is. Then I go inside and differentiate this part. This part would mean this thing. Do you understand that? So derivative of 3x plus 5. So what is my answer? 7 into 3x plus 5 the whole raised to 6 into derivative of 3x is 3 and derivative of 5 is 0. So my final answer works out as 7 threes are, that is 21. 21 into 3x plus 5 raised to 6. Do you understand this? That is precisely the chain rule. So you connect yourself with the chain rule in this way. Do you understand this?
So could you take another example?
I'll take 5 more examples for you to understand. So let's go for the next one. D by dx of sine x raised to 9 can also be written as, this sum could have been given as this way, sine 9x. Now that is as good as d by dx of sine x raised to 9. So the very first thing, what do? You attack the outside function, that is 9. 9 into sine x raised to 8 into derivative of sine x. That's your next step. Do you understand this? You go inside there. So that is 9 sine x raised to 8. It will remain as it is, as I said. Derivative of sine x becomes cos x, and that's your answer. Do you get it? One more example.
Yeah, sir.
D by dx of square root of sine x square. Okay, now please do not write it as sine x the whole square. Be careful. This is a common mistake that student does. Square and root cuts out. The square and root does not cut because the square is not sine square. It is sine x square. So how do you plan to do it now? D by dx of square root, right? So you first take care of the square root. Square root is something raised to half. Do you understand this? So what do? You say half into whatever the function is. Whatever the function is, raised to half minus 1, that is minus half, into derivative of inside thing. So inside is sine x square. Do you understand this? Now this is 3-layer work. Let's see. So first layer, square root done. Do you understand? As I said, attack the most outside thing. So you attacked this. The first layer done. Then you attack this. Second layer. You are on second layer right now. So half into sine x square raised to minus half into d by dx of sine, that becomes cos x square. So you attacked sine, so that becomes cos x square. Next step is derivative of x square. Do you understand this? So this becomes 1 by 2 sine x square into, here you have in the numerator you have cos x square. Derivative of x square is 2x. So your final answer goes as 2 cancels out, and this is your final answer. Go through this example again, right? I'll give you some more examples to work on. Let's see. Okay. So going for the next questions, we have cos square x raised to 7. You could just check your answer. I'll explain the things in details. Let's see. Here I have for cos square. So I would say this as number 1. So answer to 1. Answer to 1. Okay, so how do you go about doing it is dy by dx is equal to, the very first thing is, this is nothing but d by dx of cos x raised to 7 the whole square. So the very first thing is you attack this algebraic square outside. So when you do this, you'll get 2 times cos x raised to 7 into derivative of cos. That's your next attack. Cos x raised to 7. So now the first thing will repeat as it is, as I said earlier. 2 cos x raised to 7 will repeat as it is. Into derivative of cos will become sine x raised to 7. Now the next thing is you differentiate this x raised to 7. So derivative of x raised to 7 is left out. The chain, remember this. The outer one, if you see how do I go about attacking things. The outer one first, then the cos one, and finally this particular term. Do you get it? Right? So now if I go ahead with this, what do I get? 2 cos x raised to 7 into, do you understand this? Do you understand? So 2 cos x raised to
Yeah,
7
sir.
into sine x raised to 7. And the next thing is derivative of x raised to 7 is 7x raised to 6. Right? 7 2s are 14, and that is how it works out. I hope you understood this. So that was your first one. Just go through the solution once, and then I'll go ahead with the next question. Did you check your answer?
Yeah, sir. I got it correct.
Good, good, right? So then the next one is easy. I suppose you've already managed it. Let's go for the third one. Most probably you had a doubt with this. 7 sine x squared. So let's think of this. Here we have answer to third question. 7 sine x squared, right? Okay. So if I want to differentiate this term, the very first is 7 raised to x. If it is 7 raised to x, what would you write? So you'll write 7 raised to whatever it is. So x into ln 7. That is done. So my first thing is I'm attacking this 7 raised to x thing. That I have done. Next is I'll attack this sine. So sine ka derivative becomes, so next step I'll write derivative of sine x square. Now next step, 7 raised to sine x square ln 7. That will repeat as it is. I don't have to worry about this now. Derivative of sine becomes cos x square. And now I'll attack this x square. That's my third attack. So derivative of x square. Next I go for derivative of x square. So the last step is you repeat all these things. What do you repeat? You repeat all these things into a bracket. So here I repeat it. Derivative of x square becomes 2x. So that's your answer. I hope it is clear. Done? Okay, so next I start with one more part of derivatives. When I say this, here you have it. Say implicit function. Okay, so the derivative that we did till now are explicit ones. Now, what does this explicit means? When we have y equal to f of x, like in I have y equal to sine x, and I ask you to differentiate it, you get dy by dx is equal to cos x, whatever. So your y and x are separated. They don't intermingle and you don't have to separate and all those things. Now, implicit means they are completely combined, right? So when you see them here you have a formula. For example, let me just put an example directly. You actually don't require questions from book. I'll make questions as and when wanted. So just see this. You have x square plus 3x cube y square plus 2xy plus y equal to 7x square y. Now this is pretty tough question comparatively, right? So let me just ease out the question first and then I can go for a complicated one also. So yeah, I've eased out the question to some extent. Yeah, here you have the easy one, comparative. Okay, how do you start? So I start differentiating this. So x square ka derivative, we know it's 2x. Now this 2xy, 2 is a constant. I keep it aside. Xy acts as UV thing, product rule. So x into derivative of y is dy by dx, as we already write. See this, derivative of y is dy by dx plus y into x ka derivative is 1. Do you understand this? Did you understand? This is derivative of this xy thing,
Yeah.
right? Then derivative of y becomes dy by dx. And again, you have this 7x square y. So this 7x square y right here because I require some more space. So 7 into x square ka derivative is 2x and y remains as it is. And then x square remain as it is and y ka derivative is dy by dx. So whole of the derivative thing you've done now. But that's not your dy by dx because now comes a simple algebra which says what? Collect all like terms together. Like term in sense dy by dx together. So what do I do is I collect dy by dx together. So which are dy by dx term? 2x. So this is dy by dx term. This is dy by dx term. So plus 1. And I take dy by dx term from here. So this is 7x square which goes there and becomes minus 7x square. Any doubts till this part? And all the other terms on the right hand side. So on the right hand side if you see 7 2s are 14xy. Then you have 2y which you take on the other side becomes minus 2y. 2x which you take on the other side and becomes minus 2x. Do you understand this? So dy by dx becomes what? It is 14xy minus 2y minus 2x upon 2x plus 1 minus 7x squared. Now take your time to digest this. Go through the solution once, read it strongly, and let's see how much you understand. Right?